form. We've even reviewed it this year. But you might not realize that that form actually comes from the slope formula that we talked about yesterday. So this first part is just showing you where slope-intercept form comes from, how it's created. So I have just a general line here, and it says consider the line that goes through points A and C, where A has the coordinates 0, B, so the x-coordinate is 0, the y-coordinate is some number b, and then C is any other point on the line with just coordinates x, y. And it says notice that B is the y-intercept, so you can see that on the graph, but also from the ordered pair that x-coordinate is 0, so that means it's the y-intercept. So we can use these 2 points to find the slope of the line through A and C. So using the slope formula and these 2 points, if I were to find the slope between those 2 points, change in y over change in x, on top I would have for change in y, y minus b. And on the bottom for change in x, I would have x minus 0. And then I'm going to rewrite that because I know in the denominator x minus 0 is just x. So m is equal to y minus b, all divided by x. And now what I can do is I can solve this equation I have here for y. And I will see that when I rewrite that slope formula in terms of y equals, that it is the slope-intercept form for the equation of that line. That's where it comes from. So if I were to solve this equation for y, what would I have to do first to get the y by itself? I have to do something before I add b. I have to multiply by x first to cancel out that denominator. And rather than write x times m, I'll write that as mx equals y minus b, and then I can add b to each side. And so I'm not only adding b to each side, but then I'm going to flip it around as well so that it's y equals, and I have mx plus b on that left side there. So that's where that formula comes from. So you'll notice a lot of the time in math, one formula kind of stems from a different one. So slope-intercept form, like I said, I know it isn't brand new, but as a review, in slope-intercept form, y equals mx plus b, m represents the slope of the line, b represents the y-intercept of the line. And in order to write an equation in this form, you have to know the slope and you have to know the y-intercept. So sometimes you're given both of them, sometimes you're given one and you have to find the other, sometimes you have to find both. So for the first 2 examples, we're writing an equation in slope-intercept form for the line described. Example 1 says the slope is 4/3 and the line passes through 0, 4. So again, we need m and we need b. For number 1, we have m, we have the slope, that's 4/3. With the point that we're given, do we have b or do we have to find it? Do we know what b is or do we have to find b? I'm hearing both. I'm hearing we have to find it. I'm hearing we know it. Yes, so if you have a point, if the x-coordinate is 0, then the y-coordinate is the y-intercept, meaning then your y-coordinate is your b value. So with this point, because the x-coordinate is 0, this is the y-intercept, meaning the b value is 4. Now, if you were saying we needed to find it, we're going to be going through examples where we have the slope and a point that we need to use to find b. You certainly could do that. I'm pointing this out though because if you have a point with 0 as your x-coordinate, you already have b. You don't have to go through the steps to find it if you recognize that you have it. So we have m, we have b. substitute those into our slope-intercept form to write the equation of our line. So that's y equals 4/3 x plus 4. So make sure in the end that you are writing the equation of the line, that you're not circling M or circling B as your answer, that you're taking that extra step to write your equation. So looking at example 2, we have a line that passes through 0, -6 and -4, 10. So here, whenever you're not given the slope, that should be the first thing that you find. So I have to find the slope M first, and I find that using the slope formula, change in y over change in x. So change in y's on top would be 10 minus -6 over change in x's on the bottom, -4 minus 0. So on top, 10 minus -6 is really 10 plus +6, so 16 over -4, which simplifies to just -4. So our M is -4. Do we have B or do we have to find B for this one? Do we know what B is already or do we need to find it? We know B. What is B? -6. So this is our B value because the x coordinate is 0. So then we can go right ahead to write our equation of our line. So we have y equals M is -4x, and then I can either put plus -6 or just -6 is fine. Questions on examples 1 or 2? All right, so then before we go on to the next couple of examples, if you know the slope of a line and a point that the line goes through, you can use the point slope form to find an equation of a line. So point slope form is given in 2 different places in this box, but it's the formula that I know is part of Algebra 1 also, y minus y sub 1 equals m times the quantity x minus x sub 1. And in this formula, x sub 1 and y sub 1 are the coordinates of a point on the line, and then m is still the slope of the line. So in this type of equation, you would substitute in your slope m, and you would substitute the x coordinate of your point in for x sub 1 and the y coordinate of the point in for y sub 1. And then if you use this equation, you can solve it for y to get it into slope-intercept form. So for the next example, I am going to show you 2 different ways to do this same problem, and then from here on out, whichever method makes more sense to you and you prefer, that's how you should do it. But I'm going to show you 2 different ways to write an equation of a line for this case. So in the end, our answers should all be in slope-intercept form. Number 3, the line is passing through 5, -2 and has a slope of -3/5. So I know M is -3 over 5. For number 3, do I know what B is or do I have to find it? Am I given the B value for number 3? Is B -2? No. This is not 0 for the x coordinate, so this is not B. If you want to make a note on your sheet, -2 is not the B value. So we have to find it. So we can do that in one of 2 ways. The first way is to use slope-intercept form. So just starting off with the formula y equals mx plus b. And ultimately, I need to find m and b. So I could substitute into this formula -3/5 for m. And then since I don't know b, I can substitute the x and y coordinates of my point in for the x and y into the formula, and then I can solve for b. So in place of y, I would substitute in -2. In place of m, -3/5 times, in place of x, my x coordinate is 5, and then I keep the plus b, and I solve for b, right? Hopefully, or maybe this seems familiar, you've done this before. So to solve for b, I have to multiply -3/5 times 5. Because the denominator is 5, when I multiply by 5, they just cancel out, so it's just -3. And then I have plus b. Solve for b, add 3 to each side. So -2 plus 3 is 1, so b is 1. So now make sure you're not circling b equals 1 as your answer. You still write the equation of the line with your slope of -3/5. So the line is y equals m is -3/5 x plus b is 1. And notice in the end, too, when you write your equation, your final equation, you only substitute m and b in. You do not substitute the x and the y coordinates back in. That's only used to find b in process. Questions on that method? All right, a different method, again, to find the same answer, it's just a different way to do it, is to use the formula we just talked about, the point slope form. So that's from the other side, the y minus y sub 1 equals m times the quantity x minus x sub 1. And kind of make a note with the name of the form too, as long as you have a point and a slope. You can use point slope form. So I replace the m with the slope, and then the x and y from my coordinates go in place of the x sub 1 and the y sub 1. So I have y minus, the y coordinate is -2, equals m is -3/5 times the quantity x minus, and x sub 1 is the x coordinate, which is 5. So then what's nice about this form is once I have that substituted in, I just solve this for y, and I have my answer. I have the equation in slope-intercept form when I solve this for y. So I don't have to find b and then plug everything back into the formula. I just plugged it in once, solve for y, and I'm done. So to solve for y, I would need to, on the right side, distribute first. Distribute the -3/5 to get rid of those parentheses on the right side. And on the left side, when I have y minus -2, this is really y plus 2. So when I rewrite it, I'm just going to write it as plus 2. And I would have then -3/5 x. And then when I multiply -3/5 by a minus 5, again, the 5's cancel, so that'll just become positive 3. And now that my right side is simplified, I no longer have parentheses. On the left side, to get y alone, I just subtract 2 from each side. And I have my equation, y equals -3/5 x, and 3 minus 2 is plus 1. But then it's already in slope-intercept form. I don't have to substitute things back into slope-intercept form when I'm done. Okay, 2 different ways to find the same thing. Are there questions on either method? Whatever method you want to use is up to you. I'm not forcing you to use either one. Use the one that makes the most sense. Typically, when I go through examples, I use the second method just because it's my preference, but it's not what you have to use. All right, so then example 4, we have a line that's passing through 2 points, 4, -9, and 2, -4. So again, we don't have the slope for this one. We have to find that first. So slope formula, change in y over change in x. Change in y on top would be -4 minus -9. And change in x on the bottom is 2 minus 4. So negative 4 minus negative 9 is really plus positive 9. So that's 5 over 2 minus 4 is negative 2. And leave your slope as a fraction, a simplified fraction. So I'm going to leave it as 5 over 2. I'm just going to write the negative in front. So if either your numerator or your denominator are negative, it just means your fraction is negative. If they're both negative, then it's positive. So I have m. And now once I found the slope, now you may remember doing this in Algebra 1, I take the slope and one of my 2 points, because then I have a slope and a point, and I can just do what I did in example 3 to write my equation. But I only need to choose one of my points, and it doesn't matter which one you choose. You'll get the same answer in the end as long as all of your math is correct. Choose the point that looks simpler to you. So any preference, the first point or the second one? Which one looks easier? Second one, thank you. Doesn't matter. So I have my slope, I have my point. I'm going to show using the point slope form. So y minus y sub 1 equals m times the quantity x minus x sub 1. Substitute negative 5 halves in for m, 2 and negative 4 in for my x sub 1, y sub 1. So y minus the y coordinate is negative 4 equals m is negative 5 halves times the quantity x minus the x coordinate is 2. And then I'm just going to solve for y. So again, distribute on the right side first. I am going to change the left side to y plus 4 equals negative 5 halves x. Negative 5 over 2 times a minus 2. So again, the 2's are going to cancel out, and so will the negatives. So it's really just plus 5. And then solve for y. Subtract 4 from each side. So y is equal to negative 5 halves x plus 5 minus 4 is 1. Okay, questions on example 4? All right. Then the second part of this is being able to write an equation of a line that's parallel or perpendicular to a given line. So in algebra, we don't focus necessarily on the fact that parallel lines never intersect. We know that. We focus on the relationship between their slopes. Same for perpendicular lines. So parallel lines are lines that have the same slope. It also specifies all vertical lines are parallel. It only specifies that because a vertical line doesn't have a slope, so they can't have the same slope. They don't have slopes. But parallel lines have the same slope. That's why they never intersect. So looking at the graph, that's the visual representation. Looking at the equations of those lines, we can see they both have a slope of 2. Their slopes are the same. Perpendicular lines are lines that have slopes with a product of negative 1. So if you multiplied their slopes together, the product is negative 1. Another way to classify that is perpendicular lines have slopes that are opposite reciprocals. Their slopes are opposite reciprocals. Opposite meaning one's positive, the other's negative. Reciprocals, I think we know what that means. It means you're kind of flipping that fraction. So looking at, again, there's a visual, but looking at these equations and their slopes, the slope of the first line is positive 3. The slope of the second is negative 1/3. So one's positive, the other is negative. One is 3 over 1, the other is 1 over 3. So opposite reciprocals. So when you are asked to write an equation of a line that is parallel or perpendicular to a given line, you're looking for what that slope should be. So in examples 5 and 6, for both of these examples, we're writing an equation in slope-intercept form for a line that is going to pass through 3, -2. That's the point we're using for both. And is, in the first one, parallel to the line y equals -5x plus 1. All right, so as I've said in 2 previous examples, can I have the side conversation stop, please, so I'm not talking over people? Thank you. I realize this is review, but if I'm distracted by people talking, that means your classmates that may not remember how to do this are probably also distracted if I'm all the way up here and I'm distracted. Okay? So if a line is parallel, or as I said in a couple of the previous examples, if you are not given the slope of your line, you have to find it. Here, we are not given the slope. We are given a point our line is going to go through and a line it's parallel to, but we're not given the slope. So we have to find what our slope is. You are using the line you are given to find your slope. So if my line is going to be parallel to the line I'm given, I know parallel lines have the same slope. So I need to find the slope of the line that I'm given. What is the slope of this line? The -5. And so if my line is parallel, its slope is the same, so my slope is also -5. That is the only thing I use this line for. The +1 in that equation means absolutely nothing for what I need to do. So don't use the +1 for anything. So now I have my slope. I have the point my line is going through. It's going through 3, -2. So now I'm doing exactly what I did up in example 3. I have a point and a slope. Write the equation of your line. So either find B and plug them both in, or use point-slope form. So I'm going to use the point-slope form again. That's just my preference. So I'll write down y minus y sub 1 equals m times the quantity x minus x sub 1. Substitute in the m and the x sub 1, y sub 1 for the, or from the coordinates. So y minus the y coordinate is -2 equals m is -5 times the quantity x minus the x coordinate is 3. And now I just need to solve for y using this form. So again, on the left side, I'm going to just rewrite this as y plus 2. And I have to distribute the -5 on the right side. So that would be -5x plus 15. And then solve for y, so subtract 2 from each side. And my equation is y equals -5x plus 13. So you're only using the fact that it's parallel to that line to find your slope. And then use the points you're given to write your equation. So questions on that one. All right, then perpendicular. Now 6 is perpendicular to the same line. So we had already said the slope of the line we're given is -5, but perpendicular lines don't have the same slope. They have slopes that are opposite reciprocals. So if this slope is -5, what's the opposite reciprocal of -5? Positive 1/5. So opposite, one's negative, one's positive, and then the reciprocal. So my slope is 1/5. Again, I'm not using the +1. I'm still going through the point 3, -2. But make sure now I'm not just taking the equation I just wrote and replacing the slope, because a different slope is going to give me a different y-intercept as well. So I need to do that process again with this slope and the point 3, -2. So I'm not going to rewrite the formula again, but I'm using this point-slope form. So y minus the y coordinate is -2 equals, in place of m, my slope is now 1/5 times the quantity x minus the x coordinate is 3. So again, my left side is y plus 2, but now on the right side I have to distribute 1/5. So I have 1/5 x minus, and this would be 3 over 1, so 1/5 times 3 over 1 would be 3/5. I could change the 3/5 to a decimal, but make sure you're leaving your slope as a fraction. And then when I subtract 2 from each side, my equation is y equals 1/5 x. And if I have a negative 3/5 minus 2, I have minus 2 3/5. Or if you had the decimal, that's negative 2.6 for the y-intercept.